In this video, we are going to describe the breakpoint graph. And now, we are going to describe the two break distance. It is the minimum number of two breaks transforming genome P into genome Q. It has a clear evolutionary importance. What is the two break distance between human and ape, for example? Now, we are going to speak about breakpoint graph, and we are going to compare genomes P and Q. First of all, I should normalize the genome Q into the format A, B, C, D. And I'm going to replicate the original one as A, C, C, B, here as B, D, yes, and here I have B, A, perfect. And now that I normalize the two graphs, I'm going to superimpose them. So I have in a single graph P and Q. I can see that I have red and black edges that are the one from the P and Q graph in the same breakpoint graph. These are only the blue one, these are only the red one. And I'm going to introduce a concept called the alternating red-blue cycles. I can see that I have on this graph alternating red and blue, and on this graph alternating red and blue. And I'm going to define cycle PQ as the number of red-blue alternating cycles. Now I have a different graph, P and Q. Q is composed by two disconnected graphs by a symbol at every time A, B, C, D, E, F. So I can normalize it. A go to C and C go to F. F go to E and E go to A, and this is the graph Q. The second graph of Q connects P and D. Now I'm going to apply again to merge the two graphs, and in this case I have 3 cycles in PQ. The first cycle is this one, the one between E and F. The second cycle is this one, the one between B and D. And the third cycle is this one. Now, given P, what genome Q maximizes the number of cycles PQ? As you can see, we can call the identity breakpoint graph. And the cycle is going to the number of hours that is 4. Now, we are going to speak about genome rearrangement and how it affects the red-blue cycle. On the left, I have the breakpoint graph, PQ, and on the right I have the breakpoint graph, QQ, the identical one. And I wish to know the number of two breaks transforming P into Q. So how to pass from cycle PQ2 to cycle QQ4? I have to delete arcs. So first of all I have P that is equal to A minus B minus C plus D. My apologies because the direction of the arrow is not shown in this picture. And now I have cycle of PQ equal to. What I'm going to do is I'm going to delete these two arcs, this one and this one. And removing these two arcs, I'm going to update these arcs. And these are what I do when I remove an arc in reality is change all the vertex. I'm going to change this vertex here and this vertex of the arc here. Now I'm going to remove these two and I'm going to change this vertex here and this vertex here. I'm going to obtain the identity graph, cycle Q. And in the next class, we are going to seek the two break distances.